Today we're going through talking about setting up a program from an SSA file. As you see here, there's a lot of information contained in the SSA file. First step we're going to do is move over to our MMI. We're going to import the SSA file. You can see we pull in the orientation information, our reference, zero reference point. You can see we have our X, Y, Z data, theta, any skip information, part number, and description, as well as the reference designator. At this point, we're looking at parts that need to be registered that don't exist in our current library. Clear that error, we're going to go over to the board definition screen. You can type in your customer name, board name, XY data, and again your place origin data. All of that is pulled in through your SSA file. You can see our array data is set up in here as well. If any of this information does not translate over, it can all be added manually. Here's where we can look at our PCB array layout, and if we need to skip anything, we can do that there as well. Fiducial information is imported. We like to use a minimum of 2 fiducial points if possible, and we can use a common fiducial, or we can have multiple fiducials of different size, shape, and lighting set up on the same board. Once we've set our fiducial data, we can go ahead and start importing our new parts. Based on description, we will take known part numbers of the same package type, apply those to the part name, and make any modifications we need to. Here we're setting up our feeder size, nozzle size, pitch information, speeds and delays, and we just repeat that process for the rest of the components here. Again, we're pulling a component from our known library, and we're registering those parts. The final vision teach will be verified on the machine once the program has been completed. If you have multiple part numbers that fall under the same package type, you can group them together and teach them all at the same time and register them at the same time as well. We'll find a similar or common part type again. The last item will be our BGA. We'll go ahead and register that. So here we're showing that we can adjust our ball array. If we were connected to a machine live, we would have a camera there and we could auto detect the balls with our vision system on the bottom of the component. Once we've registered our parts, we need to go ahead and if we have anything in stick or tray, like our BGA part, we need to assign it to a tray unit before optimization. Once we've taught our pocket size dimensions for the JDEC tray, we can go ahead and optimize our program. So you can see right now we're looking at front side feeder base. You can manually assign those if you want to force them into a location. And the other thing you get is a step data or place data. And so right now we're looking at the order, and the XY location, Z rotation, and part name associated with those. Once we save that, we'll run our optimization. is going to give us our feeder array output and our best placement from start to finish for most efficiency. At this point, we are ready to run a program. Thank you for your time.